We are very happy today because we are honoring our very successful dean, Dean Frank Bromilow, in whose name this lecture series is established. So Dean Bromilow's family is here, and I will introduce Dean Frank Bromilow first, and then I'll introduce the family at the end of the lecture series. We have Bromilow lecture being delivered today by a very distinguished member. I'm proud to say she is our own alum, and she is a member of our college advisory board. So let me introduce Dean Bromilow first. This is the lecture that honors him. He had a very distinguished record as the dean. Some of the most important decisions he took involved really some experiential type of learning. We think that's a fashionable word, but back then, he was the one talking about it. There was a nice history book on the College of Engineering, actually 2 or 3 books. One entirely about jet, another about the history. So you will read some of the challenges at that time, which quite frankly are not too different from the challenges we are facing now. Dean Bromilow came to NMSU in 1951 as professor and head of civil engineering. He became a dean of the College of Engineering 10 years after he moved here in 1961, and he served until 1974, until his untimely death in that year in 1974. And his family has been so gracious, set up this lecture series. And in fact, I think, what is the number of this lecture series? 44th. This is the 44th lecture being given. And we had some very prominent lecturers. One of them included, the chancellor was reminding me this morning, he himself gave the Bromilow lecture a few years back, apparently when he was serving on our college advisory board. So this has always attracted some very eminent speakers. Let me introduce our lecturer, distinguished lecturer today, Ms. Allyson Yarbrough. She is our 44th distinguished Bromilow lecturer. She's, I should say, Dr. Yarbrough. She is a principal engineer at the Aerospace Corporation, a nonprofit federally funded research and development center that delivers space systems engineering and technical support to government and civil agencies. She holds 5 patents, is a member of the Dean's Advisory Council in the College of Engineering, and she's active with organizations that support engineering education. And she is very passionate about women in engineering, and she does have a scholarship, and we have a student receiving her scholarship. And the Women in Engineering programs continue to need support, and we are very thankful to Dr. Yarbrough for supporting those areas. She is an electrical engineering alumna, did her bachelor's from NMSU, and she continued with her master's and Ph.D. programs in electrical engineering and got those degrees from Cornell University. She has such a vast breadth of experience. I was most fortunate, along with our directors of development, to go visit her family in California. This college is truly blessed, and I keep saying that again and again, but I want to repeat that. Truly blessed to have such outstanding support from people like Dr. Yarbrough. So without further delay, I will invite you to deliver your lecture.
Thank you, Dean. Good afternoon. I'm honored to present the 44th Bromilow lecture as part of Engineering Week activities. And when Professor Bromilow arrived at New Mexico State as the chair of civil engineering, there were no more than 40 faculty members in the entire college. And then starting with his appointment as dean, 10 years later, as Dean Reddy just mentioned, he led the expansion of the faculty to almost 60 and was the driving force for creating graduate programs in civil, mechanical, and electrical engineering. and he established the departments of engineering technology and industrial engineering. Was also instrumental in attracting increased funding from the state and served the engineering profession with distinction in diverse roles over his long career. Dean Bromilow, he clearly appreciated the obligations of a land-grant institution to serve the state of New Mexico, and he applied his vision for excellence to executing those obligations. As a graduate of the Department of Electrical and Computer Engineering, I'm a beneficiary of that commitment to excellence, which has really shaped my entire educational and engineering career. And with that foundation, I'd like to share with you over the next few minutes my thoughts on engineering education and self-empowerment. Or to put it a slightly different way, I'm here to talk to you about equality, equity, and shoes. And you might be thinking, well, what do those have to do with engineering education and self-empowerment? But let me explain. Today's global career environment is competitive, it's full of surprises, it's exciting, and to succeed in it requires strong skills, the ability to adapt quickly, self-empowerment to seize control of your destiny, and education is the foundation of that success. And taking it a step further, engineering education is a powerful accelerator for self-empowerment and eventually controlling your own destiny. Especially when it's taught holistically, engineering prepares learners to be nimble and poised for success in diverse environments over the course of their careers. However we define it, isn't it true that what we're all really seeking as individuals is the ability to control our destinies and fulfillment, whether we choose a corporation, entrepreneurship, academia, advanced studies, public service, or some other role? As educators, employees, employers, parents, and mentors, we strive to produce graduates who are beyond just ready to survive the future. We want them to be prepared to define the future. And since all of us are very likely to transition between multiple jobs or careers over time, we must recognize and honor that those doing the learning, they may range from K through 12 children to undergraduates to adults, retooling their skills to improve their earning power and make a better life for their families. Graduates and workers in the science, technology, engineering, math, or STEM fields, they enjoy better job opportunities and typically earn bigger salaries according to studies by the government and industry groups. The career website that many of you are probably familiar with, Glassdoor, reports that 13 of the 25 highest paying jobs are in technical fields. U.S. News and World Report and the Bureau of Labor Statistics also rank opportunities for STEM and STEAM job seekers as the most favorable in several years. Last year, in 2018, Time Magazine's Money section reported that STEM graduates made the highest starting salaries of any other career field, while the work of Burning Glass Technologies, that's a job market analytics firm, they have shown that STEM-related graduates had access to twice as many entry-level jobs as their non-STEM colleagues. And the trend is expected to continue. The Bureau of Labor Statistics predicts that STEM jobs will grow 55% faster than non-STEM jobs over the next decade. And it's these types of statistics that encourage us, regardless of where we are along the career spectrum, that we made a good choice when we selected a technical career path. And in my experience, it's personally fulfilling, it's satisfying to be involved in technologies that make a difference in the world and develop critical thinking that prepares us to pursue lots of different career options over time. Now, back to equality, equity, and shoes. Traditionally, we have expected in engineering and education, we've expected equality, meaning that we treat everyone the same with the goal of ensuring fairness, which this seems as it should be, until now, when we realize that today's very complicated world of unexpected challenges, shifting dynamics, changing and diverse needs, it requires even more. Equality assumes that everyone starts from the same place and that everyone needs the same support. We recognize now that this is not the case, it's not the reality. Instead, I contend that what we need is equity, which focuses on giving every student, every learner, every employee, every worker what they need as individuals in order to achieve their goals. And that's going to vary from person to person depending on their abilities, interests, their motivations, and needs. Simply put, equality is about giving everyone shoes. Equity is about giving everyone shoes that fit. Let's not give a learner with needs this size or a worker needs this size with education or training that's built for a need that looks like this. It's a mismatch. This is a really important distinction because engineering education equity and the success it generates relates directly to the future ability to control one's destiny. And by destiny, we could mean being competitive in getting a higher skilled job, feeling empowerment, achieving financial stability, or greater personal satisfaction. It's defined a whole bunch of different ways for all of us. In other words, the results of education equity feed what I call destiny equity. And New Mexico State's College of Engineering excels in this realm of equity and empowerment. Just take, for one example, to be brief, take the Aggie Innovation Space. This 3-part integrated center that brings together that prototyping space, the fabrication lab, and the machine shop with evolving and upgrading of state-of-the-art equipment and software. Since it first opened in 2014, its goal has been to provide hands-on experiential learning, and one thing that's unique about the innovation space is that it's student-run, with the leadership team managing everything from budgeting for materials to operations and safety to some of the hiring. And I hear the interviews and selection process that the student managers conduct are grueling or non-trivial. The faculty and staff members describe the innovation space as a smoothly running student-centered community setting, and what I've seen on my visits to the space bears that out. Another attribute is that while organizationally it resides within the College of Engineering, the student project opportunities and engagements are open to students across campus. And I think that this mosaic of diverse perspectives and skill sets enriches the engagement, the opportunities, and the outcomes significantly. Another key element, I think, of its successful operation is the partnership with the entrepreneurs and mentors at the Arrowhead Center, and that ability to help businesses in the region blossom into viable companies that contribute to New Mexico's economic development and have students and budding entrepreneurs a part of that is one of the important pieces of the value proposition. The Aggie Innovation Space represents one of the pinnacles of engineering education equity, providing a full spectrum of learning and training modalities that fit the diverse styles in which students and learners assimilate knowledge and own that knowledge. And when students own knowledge and then can work with others to create solutions to problems that they care about, that matter to them, that's when empowerment springs forth. the realization that you can take the know-how in hand and use it creatively to meet a need. And speaking of teamwork and meeting needs, I want to change things up a little bit and ask you to participate in a little exercise with me. You'll notice that at each table, there's some very simple materials. There's some styrofoam cups and there's some toothpicks in those cups. What I would like to do just a simple illustration, just participate in this thought experiment with me. Let's say that Dean Reddy has decided, okay, the college is going to erect a new sculpture in the mall that represents the diversity, the ingenuity, the innovation of New Mexico State engineering. And he's crowdsourcing ideas from students and other members of the campus community to share with the hypothetical architectural design firm that he has selected. And you're part of that crowdsourced community. So let's do the following. Here's a challenge. Let's create the tallest structure that you can, tallest, most creative structure that you can, out of the materials in front of you. The structure in terms of the requirement, that's the requirement. Tallest structure, requirement A. Requirement B, it's got to stand on its own for 15 seconds, unassisted. The constraint is that you may only use the simple materials in front of you, and you have 10 minutes. So, I am going to start the timer. You can choose a partner. And I'm starting the timer right, let's see, 10 minutes. There we go, 10 minutes. It just has to stand on its own for 15 seconds. Tallest structure possible.
Oh, we use those as well. But it has to stand for 15 seconds, right? Good. Now we'll go to the second story.
So what I was wondering, can I?
I think maybe, yeah, 2 or 1. Now we have to put another one up. Okay, now this one is going to be exactly, just exactly. So I'm yeah, so that's what we're going to do.
The only thing is so we have 3, 4, 5, 6, 7,
Yeah, or actually, I think
yeah, there we go. Yeah, we're
it's not going to be very stable. But you know, just have to 15 seconds.
Here we go. 1, 2, 3.
So we should. There you go.
Who's the civil engineer? Is anybody here civil engineer? Yes.
Do another one. Or here. Okay.
We get a patent for this?
Absolutely.
How long does that last? 10 seconds?
Has to stand up for 15 seconds on its
Or
own.
15
That meets
seconds.
the requirement.
We have 10 minutes, right? Do this top one. He is the capstone design director for the college. We're going to be cheering. This table is copying off of us. There's some without breaking the cup. She said,
No, I didn't specify that.
It's
we
just
couldn't break
material.
the cups. I didn't say that.
Yeah, she didn't say we can break it. You can do whatever you want. Okay, now they're copying, so make sure that holds down.
People copying us, nobody's gonna be copying us.
What do we have? What's our instrument for measurement? Oh, it's Stephanie. Oh, good, all right.
We gotta take
We
measure.
have one more? That's not what, we don't have enough.
That's it,
One,
that's
two,
it, that's it, that's it, you have five. That's it.
Don't breathe.
So, excuse me, but I decided we're gonna move the, schedule to the left, and so it's not actually 10 minutes. You gotta do it in 8 minutes. Change in requirement, change in constraint, rather.
Do that.
Okay. No problem.
Thanks, yeah, no problem.
Oh, see, they didn't break the cups, I was worried somebody might be peeing on that. We thought about that, but we weren't sure if it was part of the rules. Are you allowed to break the cups?
Oh, yes.
We thought about it.
I didn't say you couldn't.
I don't know, it's gonna fall over. It's gonna fall over. How many cups do they have? Hey, you've done this before.
It's the young guy.
Oh, look at this.
It's unstable.
Never mind. That's not fair.
What's that?
I thought we had it.
We have to write it down.
Oh, because they told one.
That's not
So,
But see-
Hear this one?
You should have only went a little way on the.
How much time do you have?
Rather than.
Allison, how much time do you have?
So you have 3 minutes and 10 seconds left.
I'm not gonna change what this like.
This man's great.
Oh, I'll get out so you can like.
And, wow, look at that.
Sit down, they're doing it.
Stand up for 15 seconds.
Oh, I
That's
should-
the only requirement.
So 15 seconds without holding it? No,
Right, no assistance.
That's just a tower, that's not a structure. There we go.
Oh.
Even without that last bit, we still got.
For like 5 minutes.
Okay.
Stephanie's, they raised theirs on.
I heard that, you Lloyd.
We are the modern structure
Can I
here.
start blowing them?
That one was actually.
Okay, so maybe we can start making the measurements to see which one is tallest.
I want to see, compare Stephanie's and ours.
So what's that? 36 and a half. Yeah, Stephanie can be my help.
Yeah, I will definitely help.
Because they have the thing.
That's
You ready? What's happening over there?
22.5?
Yeah.
You gave up.
So you got
It's
the
those
base
two
here,
on the bottom.
the base that-
I'm like, you have to raise the bottom to start 3 inches higher than it was.
Actually, I'll let you take over.
Okay.
Let's
Is
see.
anybody else?
Who else is ready?
We want at least an inch higher.
We're ready. Oh, 1, 2, 3, 4, 5.
Can we get a measurement? Can we get a measurement? Oh, but I don't know.
Go hard.
Don't breathe. Don't breathe on it.
29 and a half.
Awesome.
Okay, oh, good, you're the scribe. Okay, good. We have someone
This is allowing the new tower of Pisa.
16 and a half.
Oh, Stephanie, I'm sorry, what was this, Stephanie?
16 and a half.
We should also take into account the inclination that it's actually stable.
35 and a half.
35 and a half, wow, okay.
It looks like electric engineer serving your
32 and a half.
Oh, but he's got more beads if he can get
If
it
you'd
on.
like to come back to it.
This is the most elegant structure.
We'll go with 20 and a half. I went to the two things.
Yeah, it's pretty.
I actually gave you.
I saw 52. Well, that's I can stand for 1 hour.
It's not an earthquake.
Civil engineering.
I can, acting coaches as high as possible. Oh, I'm probably be good at that.
19.
Well, anything less than 35, you don't have to.
35 and a half.
26 and a half.
How much is that?
26 and a half.
Okay.
Electrical engineers did that.
Apparently electrical engineering.
23 and a half.
They're used to building towers, transmission.
But who's building those transmission
We don't build stable towers, we build stable towers. Look at that. Stable.
I don't know what's up with State Department, you're right, that's a strong.
Okay, so are we done? All the measurements? Okay,
That's why I
and
said
so
I
I
should only
guess,
built a little bit
you
and
know,
stop and then what?
see there with 35 and a half. We give you the accolades, you get the prize for doing the most very simple materials. Okay, thank you everyone for participating. I really appreciate it. So this little exercise really illustrates one of the ways that engineering at NMSU and is taught in how problems are solved in research and in industry. You're presented with a problem with, sometimes without a lot of advance notice. You're provided with resources like time, staff expertise, access to facilities, materials, not all of which are really exactly what you need, and usually or often not in the quantities you would like. Sometimes the requirements change on you, where we had 10 minutes at first and then I squeezed it down to whatever, 8.5. So things changed over the course of a problem getting solved and executed. Nonetheless, the customer, the manager, the stakeholder, the researcher expects you to join with others of similar or sometimes divergent expertise to create a meaningful solution on time and within the limitations specified. Once empowered with technical competence, confidence, soft skills like time management and being active listener and being flexible and being accountable, you and your team then create an acceptable solution. Might not be an ideal solution, but one that meets the need. This exercise demonstrates an analog or a parallel to the opportunity provided by our College of Engineering and, for example, Aggie Innovation Space, the Engineering Leadership Institute, the Torres Family Learning Communities. And underpinning this platform of opportunity are all the supports that learners might need, including supportive faculty and staff, graduate and peer advisors, mentors for returning and non-traditional students, professional society student chapters, cultural supports, and more. And back to my theme of equity, the College of Engineering works to ensure that when students graduate, they possess the technical competencies, the soft skills, and the self-confidence to succeed in whatever endeavor they choose to pursue. In other words, empowerment and the ability to define and control their destiny. And this empowerment has truly special meaning for me because it has directly impacted my family and my life. After 26 years as a jet aircraft mechanic in the Air Force, in 1977, my dad, Fred, decided to retire from the Air Force and complete the college degree that he had pursued for many years across many duty stations. He and my late mother moved from Cannon Air Force Base in Clovis, New Mexico, moved to Las Cruces, built a house, and Dad enrolled in the Engineering Technology Department here as a returning student at age 45. I had enrolled in the Electrical Engineering Department 2 years earlier as a freshman. Furthermore, my sister Shelley started out in chemical engineering here the same year as Dad, and Mom, not to be outdone, she enrolled in the Family and Consumer Studies program. And the only reason my brother Brian wasn't here was because he was in middle school. But anyway, so at one point, 4 Yarbroughs were on campus as undergraduates at the same time. And my dad's experience across electrical and mechanical systems and management in the Air Force was a great baseline, and his NMSU education took it to a whole new level. There is nothing that makes me more proud than to recount the admiration I have for my dad's courage and vision and persistence in earning his mechanical engineering technology degree later in life. His experience was even documented in newspapers in the area. Upon his graduation, he walked right into a job for him waiting at what was then Hughes Aircraft in Southern California, and then some years later was lured away by a competitor where he enjoyed another long and fruitful engineering career. I tell this story to illustrate how impactful an engineering education can be, even when you start from very, very humble beginnings. My dad says that as a result of his engineering education at NMSU, he's been able to achieve things he had always envisioned, and many that he never dreamed of. And that sounds like fulfillment, empowerment, and control of one's destiny to me. I'm fortunate to have had him and my mom as role models. They inspired and embodied excellence, just like Dean Bromilow did, and are responsible for any accomplishments I have achieved to date. Through the Bromilow Faculty and Staff Awards, the family continues the legacy of high standards and service to the profession. It's a privilege to follow that example and also honor my parents' dedication to excellence through the Yarbrough Family Excellence and Innovation Opportunity Fellowship, which helps pay the wages of a student in the Aggie Innovation Space. STEM professionals create the things that we rely on every day and that make society work. Being in a STEM-related field is a definite advantage in the job market and for entrepreneurial adventures because the demand for such skills continues to accelerate. So with an engineering education, in my opinion, there is no limit to how far you can go on your path to success, thanks to those shoes that fit. Thank you for the opportunity to present the 44th Bromilow lecture, and thank you for participating in our little design challenge, and I wish everyone a happy National Engineers Week.